Hey everyone, great to be here. I came from California for this, so it's really nice to be in Paris, even though it's been a big weather change for me in terms of but I grew up in Canada, so I'm a little bit used to the cold, although it's been a long time since I've been there. So this is what if privacy had an API. So I took this picture yesterday of the API landscape poster that's out in the main area in the entryway. And there are literally, essentially APIs for everything. There's APIs for sending text messages, for sending emails, for doing machine learning, sentiment analysis, creating cat memes, all these different things. But if you look at this landscape of APIs, there's no quadrant here essentially for privacy. And this question of essentially, what if privacy had an API is really what the company that I work for, Skyflow, was sort of founded around, was this question that we asked ourselves of, could we create essentially an abstraction for the challenges and difficulties around data privacy, data security, compliance, and so on? And I think to really understand how hard that is to do and how to actually go about doing it, we need to kind of take a step back and look at sort of the big picture of why is data privacy such a hard problem to solve for different companies. So if you look at the last 20 years essentially of development, we've had a kind of a rather cavalier approach to how we essentially collect and manage customer data. This like move fast and break things mantra that was started or popularized by Facebook. That's essentially been the product philosophy of a lot of different companies. And there's been a heavy consequence to essentially this way of building products, where we've not really been that concerned about how we're actually collecting data, what data we're collecting, how we're using it, why we're collecting it, and so on. And in combination, we still essentially applied 1980s type thinking to the data that we collect in terms of we don't really distinguish data based on the sensitivity of that data. So if we're storing information like someone's home address, that's still just strings or integers or ones and zeros that we're storing somewhere within a database or in a backend system, the same way as a click on a web page. And we're not really thinking about these things as fundamentally different objects. And that essentially, this combination of product thinking and this treatment of data has led to the world that we live in now, where there's essentially a major data breach by a major company on essentially a weekly basis. If you pull out your phone and search on Google News for data breach, and you don't believe me, you'll essentially see the results of stuff like this, where there's been data breaches by Twilio, Robinhood, Uber, the IRS in the United States, the San Francisco 49ers, like all these things have happened in the last 12 months. There's a company called Chegg, if you haven't heard of Chegg. They had their 4th data breach in the last 3 years. Recently, they're under investigation by the FTC now. And if you don't know what Chegg does, Chegg is a homework assistance app for children. So they had a data breach of 40 million children's records recently, which is really, really scary stuff. And I think it naturally makes you ask the question of, why is it that these super well-resourced companies with tons of tech talent that are solving all of these really complex problems are still having such a hard time dealing with this issue? And I think besides the sort of historical reasons I mentioned, I think the sort of basic answer to this is that for the most part, it's not their problem to essentially protect the data. If you work for Uber, your job is essentially, how do I deliver a driver to a client as efficiently as possible? And that is the prime directive of the company. That's what they hire their tech talent to essentially solve. That's what they're thinking about 24/7. So they don't necessarily have the resources or the focus to think about the challenges of how do we actually protect that data? What are we doing with it? And it's essentially an afterthought. And fundamentally, the big problem for a lot of these companies is not recognizing that essentially all data is not created equal. Some data, and we're talking about sensitive customer data, so things like people's home address and their financial information, their healthcare information, simply requires better protection than other forms of data. And essentially, fundamentally, this data is special. And because it's special, it doesn't belong, or it shouldn't be treated essentially the same way as other application data. So if you think about special physical documents, things like my passport, my green card, my children's birth certificates, I don't keep those in the junk drawer in my kitchen with my batteries and my flashlights, because they're fundamentally different objects. If someone broke into my home and stole my batteries, it's mildly annoying, but it's not that big a deal. I can get new batteries. If someone steals my daughter's birth certificate, well, not only do I feel like I failed as a parent, but the information on her birth certificate, her date of birth, her name, the other information that's there, isn't replaceable. Once it's out forever. You can't cancel your date of birth and get a new one. So the impact to an individual when this information is essentially part of a data breach is massive. And with time, there's been essentially more impact to businesses as well in terms of losing consumer trust, as well as fines that are starting to happen. And but even with the combination of essentially consumer demand to understanding the impact of essentially giving up their data to these different companies, as well as the regulatory pressure, it's still a really hard problem to solve. And a lot of that has to do with essentially the way that we build systems. So if we take a simple example here, where we have an application front end, we have a back end, database, data warehouse, and so on, if we are collecting certain personally identifiable information, let's say someone's phone number, what ends up happening in most systems is we take that phone number and we essentially pass it through all the downstream services of the nodes and the edges in the graph, and that phone number ends up with a bunch of different copies of the same information in all these different locations. And that increases the number of potential attack surfaces and the number of places that essentially you need to try to protect that information. So the problem here is essentially you end up with sensitive data copied, fragmented, and replicated throughout these different infrastructures. And this is a pretty simple example. A modern infrastructure is much more complicated, a lot more nodes and edges and so on. And this is a problem because imagine if you took, instead of having a single copy of your passport, which right now is in the safe in my hotel room, you made 1,000 copies, and then you distributed them all over Paris, and you tried to protect all those locations. That's a much harder problem, and I would strongly advise against doing that, than essentially having one copy that's in the safe in your hotel room. But that's what we would do with data. We essentially copy it all over the place, and then we try to retroactively or reactively protect it. So what companies end up doing is they reactively try to apply different point solutions to this broken system. They add in some encryption, maybe a little bit of tokenization to certain sensitive data. They try to harden their security models. They realize that all their developers have access to essentially their customer data in the production database. That seems like a bad idea, so then they sprinkle in some data governance and so on, and they add all these different sort of Band-Aids on top of something that's already broken. So they're stitching together essentially this duct tape and chicken wire solution on top of something that's already broken. But if you have a broken arm and you put a Band-Aid on it, it's still a broken arm. So we're not really addressing the fundamental problem, and that's why we end up with essentially a continued series of data breaches from all these super well-resourced companies because they're not solving this problem essentially from first principles. So how do we do that? Well, that's the big question, right? So if we look at some of the leading technology companies in the world, companies like Apple, Google, Netflix, these are companies that are typically not showing up in the news because of data breach. And the way that they address this challenge was by pioneering a technology known as a zero trust data privacy vault. So their key insight was that they recognized that their customer data, which is core of their business, is something special. So they moved their customer data out of their existing systems and into the zero trust data privacy vault. And what that does is it creates an isolated, protected, single source of truth of their customer data, similar to having that one copy of your passport rather than 1,000 copies. And it effectively de-scopes their existing systems from essentially the responsibilities of data security, data privacy, and compliance. So a data privacy vault essentially is a technology that isolates, secures, stores, and tightly controls access to manage and use sensitive data. You can think of it like a specially designed storage medium designed for essentially protecting your sensitive customer data and allowing you to actually utilize it in all the ways that you want to utilize it, but doing it in a privacy-preserving way. So if we go back to this problematic system where we had this challenge of not knowing what data we're storing and where we're storing it, and as an example of that, essentially earlier this year, the FTC asked Facebook to supply a list of locations where their user data is. And Facebook supplied a list of 56 databases where they think their customer data is or their user data is, because they don't know. And the former head of security at Twitter also came out and said Twitter has no idea where your user data is, which is mildly uncomfortable. But that is essentially the problem here. When we introduce the data privacy vault, things get a lot simpler. So essentially what we want to do whenever we're collecting sensitive data is we want to essentially de-identify it as early in the life cycle as possible by moving it into the special location. The data privacy vault is essentially designed for isolating, protecting it, and creating a single source of truth. And we can do that through simple APIs. And the data privacy vault is going to return essentially a pointer in the form of a token. You can think of a token as essentially a random string that essentially is de-identified or non-sensitive data. So now when we pass the data downstream, we're just passing essentially the tokens that can be a stand-in or a reference to the original values. We can still run analytics on tokens if necessary, as long as they're consistently generated. And now the log files essentially have tokenized data as well. So even if they get compromised, it's just random strings. And effectively what we've done is de-risk the entire surface area of the system, because now it doesn't actually contain any sensitive data. And any sort of operations against sensitive data are going to happen within the data privacy vault. So in the movie Back to the Future, there's this line essentially about how the flux capacitor makes time travel possible. And it's this key insight, essentially, the data privacy vault that makes an API for privacy possible. Because once you essentially have this location that you can store this information, and you have all this built-in, essentially, security and privacy-preserving technologies, you can abstract that away, that complexity away through APIs. So that's what we've been doing at Skyflow. And we're going to talk a little bit about the evolution of this API. So what we started with was essentially, how do you secure the data? So we need to build essentially secure data source with built-in privacy-preserving technology like tokenization, data masking, polymorphic encryption, which is something that we pioneered, which allows you to not only store data encrypted during transit and during rest, but actually in memory. So when you perform operations on the data, it's against fully encrypted data. Once you have secure storage, you need ways to essentially govern access to it based on the principles of zero trust, audit the data, manage the encryption keys properly. You need a way to deploy this to essentially cloud infrastructure. We need secure workflows so that we can actually execute things like custom code directly within the vault environment, allowing us to perform operations on the sensitive data the way that we normally want to do, but insulated from our existing systems. And that includes essentially passing the data to third parties to do things like send an email or a text message, move money, issue a payment transaction. So now, once you have all these sort of layers built and this technology built, now you can essentially add a layer of APIs and SDKs that become the interface of applications that essentially don't want to have to deal with building this type of complexity themselves. So we don't have time to go into all the sort of components, but we're going to look at how do we essentially govern access to the data through APIs. So how do you control access to the sensitive data? It's one thing to sort of lock it up and throw away the key, not super useful. So you need a way to actually use the data, but you don't want to make it so that everybody has access to the data. You want to control access based on the business requirements of the user or the service that's accessing the information. So how can we limit access? So if we have something like this where we've essentially tokenized a bunch of sensitive data, now we want to detokenize it, return it to its original value or a mass value. How can we do that? How can we actually guarantee that the person that's calling this has the rights to see this information? So what we created was a policy-based access control model. So you have users, you have service accounts. Service accounts is how you programmatically access the APIs. These can be assigned to roles. Roles essentially have policies assigned to them. And we created our own policy language, which kind of is English-like or SQL-like, where you can essentially specify exactly what columns and rows a particular role has access to, based around the principles of least privilege. So here, essentially, we're allowing read on the name in plain text, and we're allowing read on the credit card in a form of mass data. And we essentially want to control this based on around what the user actually needs to see to perform their job. So we'll take a look at a simple example here. So I'll jump over to a demo. So here we have a couple different roles: admin, marketing, and customer support. So the marketing person, essentially, they need name, they need email, they don't need someone's social security number, and they don't need to know how old somebody is, but maybe they need the month and the day so they can send that person a birthday announcement and state. So you can control that through these simple, essentially, policies that you can set up through APIs. And here, as 3 different rules for essentially showing some data in plain text, some data redacted, and some masked. Now, a customer support person needs access to even less information. So they need, in this case, they have the name, they have last 4 social, which is something used for validation in the US, and the state. And further, there's actually a row level restriction where this person can only see the records of people located in Arizona. And if you look at something like the Robinhood data breach that happened last year, a customer support person was essentially socially engineered to giving up their credentials. But then, and those things happen, but then that customer support person had access to 6 million customer records. Like, why? They really only need access to the people in their queue at any given moment. And by essentially controlling access based around those types of business requirements, based around the principles of least privilege and zero trust, then even in the worst case of a data breach, that customer support person might have leaked like 10 records that were in their queue rather than 6 million. So that's some basic access control. And now the next thing we're going to look at is dynamic, essentially, access to sensitive data. So it's one thing to hard code these policies, but a lot of times our understanding of who someone is in our application is based on our own auth model or maybe a third-party service like Auth0 or something like that. And we have certain understanding of a user and maybe their relationship to other users. For example, a doctor should be able to only access their patient records. So how can we essentially take into account dynamic information that exists outside of the Vault architecture within our own business application, but apply that to these policies so that we can control access dynamically? So we had looked at a rule like this where we're allowing essentially read on persons for the state of California. We don't want to have to create essentially a different policy for all 50 states in the US. So how can we make that more dynamic? So we want to be able to essentially pass in an ID value from our application as part of our auth model and take that into account as part of the policies. So what we came up with was something that we call context-aware authentication. So in this case, we can essentially make the state a dynamic variable, which we call CTX or context. And then as part of essentially signing the JOT token, we can pass in a contextual value, in this example, of state, and essentially state will become whatever that value is in there. So we can set that programmatically, essentially, from the application and pass that into the Vault so that these policies become dynamic. So now when we have something like, I only want to allow a person to be able to read the record that they own based on my understanding of who that user is, we can essentially create a policy like this, and the auth model is going to work like, in my application, I have a front-end SDK. The front-end SDK is going to request a bearer token from my back-end. My back-end knows who that user is based on however my auth model is set up, and I can get that person ID. I can add that person ID essentially to the JOT token when I authenticate with that context against Skyflow. It's going to return the auth confirmation. Now I have a bearer token that's essentially restricted that user to being only able to see the row of data that they own. So now when I detokenize data, even if I stole someone else's tokens, I wouldn't be able to actually retrieve the original values because I only have access to a singular row of data. Okay, so we're going to look at one more example here, which is essentially how can we do something where a little bit more complicated, where we have a relationship information that's stored outside of the Vault. So in this example, it's a teacher needs to access their student records, or you can think about it like a doctor needs to access their patient records. So it's not the records that they own, it's records that they're essentially associated with. So in this case, it works similar where we can attach essentially a context value based on the identity of the teacher. And then when we need to retrieve the records based on the restricted context, say we have a Vault with records like this where we have our students and we have some sort of teacher ID associated with it, we can create essentially a policy that allows read on the students where the teacher ID equals the contextual value that's passed in as part of the JOT token. So that means essentially teacher A can read Bob Anderson and Henry Davis's records, and teacher B can read Julie Bird and Sally Smith. And then essentially we can return those results based on our understanding of who that teacher is and what records they should have access to without essentially having that information stored all within the Vault and hard-coded in these different policies. So essentially, what we're doing by introducing this concept of the data privacy vault is we're making data privacy an architectural decision. And it naturally shifts privacy really far left to essentially the time when we're putting together a system. And by making essentially privacy an architectural decision, then suddenly a lot of the challenges around data privacy, data security, compliance, even things like data residency become as simple as a handful of API calls. So I want to thank you. Thank you very much. I don't know if we have time for questions or not.
Thank you very much, Sean. So, time for some questions. Who wants to know more about Skyflow or Privacy API?
So you likely mentioned data residency. Mm-hmm. That's something you are doing in storing data, for example, if you are citizen in Europe, if you are Chinese in China.
Yeah. So I didn't really have time to go into that talk, but essentially what we're doing when you have the pattern of the data privacy vault, you're essentially naturally sharding the data that's the regulated data. So then all you need to do essentially is deploy vaults to whatever regions in the world that you're operating in that have data residency requirements. So we have lots of customers that have a vault in Canada and a vault in the US and a vault in Germany or something like that, Singapore. So and then your central data center can essentially stay the same because now you're only dealing with tokenized forms of that data within the central data center. So you don't need to replicate your entire system to these different areas. You're only essentially doing a very small piece of your system in terms of the vault.